All right. Good evening, good afternoon, good night, good morning, depending on when you're watching this video. In this video, we are going to be working through exercise 2, studying the relationship between hypothesis tests and confidence intervals, from slide 33 of lecture set 8. All right, so in this problem, we have suppose the mean shell length of 583 randomly selected specimen of a sea snail species. Oh, I said that pretty good. Is 13.25 millimeters with a sample standard deviation, little s, 2.5 millimeters. At the 5% level, is there evidence to suggest that the mean shell length is less than 13.5? Okay, so first thing we're going to do are the assumption check. All right, so we're looking for a simple random sample. We're told that our sample is randomly selected, so that's good enough. Again, really, with the first assumption, what we want to know is that the sample is representative. So as long as it was collected using some sort of random selection process or a probability sampling process, that is sufficient for that assumption. Okay, our second assumption is going to be that X bar is normal. We don't know where the population came from, but we have 583 observations. So that would mean that we can use the CLT in this case, which states that X bar is approximately normal. And then our final assumption is that sigma is known. We don't have this, but that's okay. It just means that this is going to be a t-test, right? All right, on step 1, so we want to test if there's evidence that the shell length is less than 13.5. So our null hypothesis will be mu equals 13.5 versus the alternative mu is less than 13.5. On step 2, we give our significance level. We want to test at the 5% significance level. So alpha is 0.05. All right. And then on step 3, we're going to compute the test statistic. So we'll have 13.25 minus 13.5 divided by 2.5 over the square root of 583. All right, so that gives us negative 2.41. 414. 415. Okay, so now on step 4, we can take either the critical value approach or the p-value approach. If we take the critical value approach, okay, we start by sketching our t-curve. So that's shown here. All right, now it's a lower tail test. So our critical value and the rejection region are going to be in the lower half of the curve. Okay, so this area here is a size 0.05. All right, and then here we have negative t alpha n minus 1 is negative t 0.05 comma 582. Okay, so our critical value is a t-value is 0.05 and 582 degrees of freedom. So we go to our t-table and we scroll down and we see that 582 is in between 500 and 600. When working with the degree of freedom, we always round down, okay? So even though our degrees of freedom is 582, we still round down. And this is true anytime you're looking for a degree of freedom on the t-table. So we round down to 500. We have 0.05 as the subscript value. Okay, so that gives us 1.648. Right, so we go back here. Our critical value is negative 1.648. Right. Our test statistic is negative 2.415. So that means that our test statistic is here, which is inside the rejection region. Okay, so this is giving us evidence to reject the null. Okay, so then if we take the p-value approach, we start by sketching our curve. We do the same thing. So now we mark down where our test statistic is. So here's t negative 2.415. Again, because it's a left tail test or it's a lower tail test, the p-value is the area below the test statistic. Okay, so the p-value is to the left of negative 2.415. So what we would have here is the p-value is equal to the probability that t is less than negative 2.415. All right. Okay, so this is actually equivalent to the probability that t is greater than 2.415. So because of the symmetry of the curve, being less than the negative is the same as being bigger than the positive. So we go back to our t-table. We have 500 degrees of freedom, as we previously established. We're looking for 2.415, which is in between 2.334 and 2.568. Okay, so our value is in between these two numbers. Right, so our area, the p-value is going to be between 0.01 and 0.005. Okay, so we would say here, since 0.005 is less than the probability, okay, I'll write that down here. Which is less than 0.01. 0.005 is less than the p-value is less than 0.01. All right. Okay, so now on step 5, okay, if we take the critical value approach, we would reject H0 since t is in the rejection region. And if we take the p-value approach, we would reject H0 since the p-value is less than alpha. Right? And this idea here, so the p-value is a number between 0.005 and 0.01. So the biggest value the p-value can equal is 0.01, which is 1%. The significance level alpha is 0.05, which is 5%. 1% is less than 5%, so the p-value must be less than 5%, so we can reject. And then on step 6, we would say at the 5% significance level, the data provide sufficient evidence to suggest that the mean shell length is less than 13.5 millimeters for these species. All right. Part B. Find a 90% confidence interval for mu. All right, so in part B, the assumptions are exactly the same. Okay, so the confidence interval and the hypothesis test share the same assumptions. All right, so now on step 1, we have t alpha over 2 n minus 1 is t, or sorry, we should write down alpha first, right? Okay, so we have alpha equals 1 minus 0.9, which is 0.1. So this is t 0.1 over 2, 583 minus 1. So this is t 0.05, 582. All right, so we go to our t table, and again, we have 582 degrees of freedom. We have 0.05. So we scroll down, we take 500. We always round down. So we're going to use 1.648. So here we would say that this thing, the t value is approximately 1.648 because they're not exactly equal anymore because we've rounded down to use the 500 degree of freedom value. So this is approximately true. All right, so now on step 2, we have x bar plus or minus t alpha over 2 n minus 1 multiplied by s over the square root of n. So this is 13.25 plus or minus 1.648 multiplied by 2.5 over the square root of 583. So this is 13.25 plus or minus 0.171. And that gives us 13.079 to 13.421. All right. So now we can conclude by saying we are 90% confident that the mean shell length for this species is between 13.079 and 13.421. 90% confidence that mean shell length for this species is between 13.079 and 13.421 millimeters. All right, now in part C, it says, compare the results from A and B. Do they agree? Okay, so the result from A is saying that there is evidence that the mean shell length is less than 13.5. Okay. Right. So A says evidence mu is less than 13.5. Right. B is giving us an interval where every value in the interval is less than 13.5. The highest value in the interval is 13.421, which is smaller than 13.5, right? So this is every possible value for mu is less than 13.5. Okay, so therefore the two agree. The confidence interval is saying the mean is between 13.08 and 13.42. The hypothesis test is saying that there's evidence that the mean is less than 13.5. So that's the same conclusion. They're basically saying there's evidence that the mean is less than 13.5. So the two agree in that both suggest mu is less than 13.5 millimeters. All right. Okay, so as always, if you have any questions, please let me know.